Hello everyone. So today we're going to talk about multiplying brackets again. Um, Today in particular we're going to focus on questions where the power of the variable increases. So in this first example here, you'll see what I mean. We have 2x multiplied by x plus 1. So again, the way we do this is we multiply the term outside by the first term inside and by the second term inside. So if we multiply 2x by the first term, x, the 2 won't change because 2 times 1 is just 2. And x times x then will give us x squared. Now when we multiply 2x by 1, 2 times 1 is just 2, and then x will stay the same. So this is an example of one where we have multiplied it out and the power of the variable has actually changed as a result. What we'll do now is we'll look at a slightly harder example. So here's a harder example. Something that might jump out at you straight away about this first bracket here that we're multiplying is that there's three different terms in it. We have x squared, we have 2x, and we have minus 1. So we're just going to use the same method again. We're going to multiply our outside term by x squared, multiply it by 2x, multiply it by minus 1. And that's exactly what you do if there's 4 terms there as well, or 5 and so on. Just multiply it by each of them in turn. 2x by the first one, 2x by the second one, 2x by the third one, etc. Over on the right hand side, we're going to use the same thing. You have two different terms, so we'll multiply x squared by the first term and x squared by the second term. So let's get started on that now. 2x times x squared, well, the 2 is going to stay the same, and then the x's can multiply. So x times x squared, if you want to imagine this being little x to the power of 1, you can. And we just add the powers, so that's going to be x cubed. When we multiply 2x times 2x, well, 2 by 2 gives us 4. Remember, we always multiply the numbers first. Then x by x gives us x squared. And then 2x times minus 1, well, 2 times minus 1 gives us minus 2. And then the x just stays the same there. Over on the right hand side, if we have x squared times x cubed, again what we do if we are multiplying two of the same variable where they have different powers, or any power really, you just add the powers. So the x will stay the same, but the powers are added. So that will give us x to the power of 3 plus 2 is 5. And then last but not least, we have x squared times 1. So that just stays as x squared. If you want to imagine there being a number there, it would be 1 times 1. This gives you 1, and then x squared stays the same. Now this is an interesting example because there's actually a couple of things we can add to try and simplify this and clear it up at the end. We have a couple of like terms that can be added. So just our x squared here and our x squared here might be worth adding together to simplify our answer. So we'll rewrite this first of all, going in order of the biggest powers down to the smallest powers. So we can say we have an x to the power of 5, we have plus 2x to the power of 3, plus 4x squared plus x squared, which we already said we could add together, minus 2x then at the end. So we've gone in powers from the biggest down. X to the power of 5 to the power of 3 to the power of 2, then to no power to the power of 1. So then the last thing that's left to do is just to simplify those two like terms. So we'll rewrite out the rest of the equation. X power of 5 stays the same, 2x to the power of 3 stays the same, and then 4x squared plus another x squared will give us 5x squared minus 2x. So just again, that last little thing that we did, we had 4x squared and another x squared. So we just added them together. If you want to imagine there being imaginary 1 whenever you see just an x or an x squared. So if you have 4 of something, you add 1 of it, then you end up with 5 of it. Okay, so that's 2 different examples. I'm going to ask you to have a go at a few questions now, and if you have any problems, just let me know.